Inequalities. The first thing, the way we have to write our problems, we're now going to write them in interval notation. No longer are we going to write x is less than or equal to 5. Those are no longer answers. You need to write it in interval notation. I'm just going to put everything up here.
So in the example, what are we get? Whoa.
I'm going to let C and D be real numbers, as long as C has to be less than D. In brackets, C comma D. That really means C is less than or equal to X is less than or equal to D. If I have C is less than X is less than D, it's parentheses. These are all called bounded because they have a starting point and an ending point. They start at C, they end at D. For the example I threw up on top, X is less than or equal to 5. That is called unbounded because it only has one point. Now looking at this problem up here, if I want to write this in interval notation, is this bounded or unbounded? Unbounded, because there's only one point. All right, are all my points going to be less than 5 or greater than 5? They're all going to be less than 5. So the smallest number goes on and on and on and on forever. It's negative infinity, comma, 5, bracket. It is bracket because it's the equal to. If that wasn't there, if it was just an equal to, this here would be a parenthesis also. Okay, if x was greater than 5. If I have greater than 5, all the numbers are going to be bigger than 5, right? So it's going to be 5, comma, infinity. All right? And they're both in parentheses. If I change this and went negative 3 less than x less than or equal to 7, how do I write this one? What's my smallest number? So negative 3, comma, 7. Is negative 3 a parenthesis or a bracket? Parenthesis. 7 is bracket. There's your answer. That's how you write them. Because it's not equal to for the 3. And it's always small number, comma, big number. Now, when we wrote negative infinity, comma, 5, why did infinity get a net or get a parenthesis? Nothing can be equal to infinity. Infinity is always a parenthesis. Let's do this problem. What do I have to do first? I have 1/3 x minus 2 is less than x plus 4. What do we want to move first? I'm going to move the negative 2. I'm going to add 2, add 2. What else am I going to do? I'm going to do both things in one step. Move minus x, minus x. I want to move so my variable's on the left. This is just me. It doesn't matter which one you use, bless you. 4 and 2 is 6. What's a negative 1, or sorry, what's a 1/3 and a negative x? Let's see, this is 3 over 3, so it's negative 2/3 x. What do I do now to solve? Multiply by the reciprocal, so multiply by negative 3 halves. Multiplied by negative 3 halves. Because it's a negative here. X is greater than, let's see, negative 9. I have x is greater than negative 9. Whenever you multiply or divide, you change the symbol. Or multiply or divide by negative. So I need to write this in interval notation. Is this bounded or unbounded? Unbounded. Is it greater than or less than? Greater than. So how do I write it? Negative 9 comma infinity. Infinity is always parenthesis, and that's going to be parenthesis. That's my answer. This is what I'm looking for. Because I have an x over here and not an x on this one, it's going to cause a problem. This is a compound and statement. I'm going to break it apart. 2 is less than 3x plus 5. And I'm going to have 3x plus 5 less than or equal to 2x plus 11. It has to get broken into two problems. Solving this one first. Subtract 5 over negative 3 less than 3x. Divide by 3, negative 1 less than x. All right, over here, subtract the 2x and subtract the 5. I have x is less than or equal to 6. I can put the and statement back together if I wanted. Because this right here overlaps with this right here. It actually says negative 1 less than x less than or equal to 6. Writing it in interval notation. Smallest numbers, negative 1 comma 6, parenthesis, bracket. And that is your answer. What do I have to do first? I don't have to separate this one. I can. You don't have to separate them. The only time you have to separate them is when they don't match up with things balanced, where you have x's and x's, numbers and numbers. There's just numbers on this side. Subtract 3, subtract 3, subtract 3. 7 less than negative 5x less than 15. Divide everything by negative 5, negative 5, negative 5. You're right, you're going to get the same thing, you just broke it apart. Negative 7/5 greater than x greater than negative 3.
But ain't negative 3 small?
Negative 3, because the problem got flipped backwards because of dividing. Negative 3 is the smallest number. 7/5.
They both were.
Both parentheses. There's my answer. That's it. So for this problem, first thing I'm going to do is move everything over. X to the 4th plus 10x cubed plus 21x squared minus 40x minus 80 is greater than 0. So I type all that into the calculator. All right, some of you might have already had it in your calculator from the other class, leaving it there. Zoom, 6, it graphs, and it does this. Now, what do I want to know? I want to know when it's greater than 0. What is greater than 0? What are we talking about here? We want to talk about when the y is greater than 0. So I need to worry about this point and this point here because it's everything above 0 is what I want. So I need to find out what this point is and this point is. You know how to do that. All right, find the zeros. Second trace, 0. Looks like 1, 2, so I'll use the left bound as -2, right bound is 0. Guess it doesn't matter. I have -1.53. Now, x is going to be less than -1.53. Why is it less than?
That's the lowest number.
Well, that's the lowest, but it's also anything I put over here. What's my graph going to be? My graph's going to be on this one. Like this one's this. This goes to there. But if it's in here, it goes down to the other graph. Second trace, 0 for the other one. Left bound, I'll use 0. Right bound, I'll use 3. Guess, doesn't matter. X is greater than 1.89. Now, what type of statement would this be?
Or statement.
This one's an OR statement. Because I really can't, if I tried to rearrange it into an AND statement, it'd be -1.53, that. It'd be something like that, but if I did the AND, it's this and that. So it's less than this. What's less than mean? Okay, how can I rewrite this in their interval notation? They're both parentheses. What's my smallest number? No. Negative infinity 1.53. That's for this point. Because it's an OR. Or then I have 1.89 comma infinity. And that's my answer. How about this one here? When I use a quadratic formula, -3 plus or minus 3 squared minus 4 times a times c all over 2 times a. -3 plus or minus square root of something over 4. 9 plus 32 is 41. Doesn't make sense for our problem to leave them as radicals. So I'm actually going to go in -3 plus the square root of 41 divided by 4, 0.851. I'm going to do the negative part of it. -2.351. Is this an AND or an OR statement? I should be able to tell without graphing. Why is it an AND statement? There's a way you were taught back in Algebra 1 and Algebra 2. And the way to tell if this is an AND or an OR. Why was this one an AND statement? Or sorry, why was this one an OR statement? And why is this one an AND statement? Or AND. When it is greater than, it is an OR statement. When it is less than, it is an AND statement. It's the easiest way. And I think the book explains it's putting it in the calculator and finding out when it is. The easiest way to remember it, if it's less than, it's an AND. So what's my smallest number? -0.2351, comma, 0.851. It's equal to, so they both get brackets. Questions on this section?